So I think we're going to get started. Thank you very much for waiting. Welcome to the third in a series of discussions looking at material health. This evening we're talking about transparency in material health in practice. My name is Alison Mears. I'm the director of the Health and Materials Lab at Parsons School of Design in New York City. Welcome to this evening. We're joined this evening by 4 experts in their field who are going to share their wisdom about what it's like to implement some of these thorny issues of material health in practice. So we greatly appreciate their being here. Wendy Vittori is here moderating again this evening. So I'd just like to introduce our participants this evening. John Amatruda, who's right there in the middle, because he's A and super goes first. He's principal and leader at
All my life.
And Wendy's reminding me to go to the next slide. Which doesn't seem to want to go. Oh, there we are. Just hope it doesn't hop over. Okay, so John Amatruda there on the left-hand side is principal and leader at Vidaris' Green Services Department. He specializes in environmentally conscious design and the evaluation of green materials and systems. He's worked as a consultant on over 90 LEED projects nationwide and internationally, using all variations of the LEED commercial program, and was named a LEED Fellow in 2013. And you've been watching this series. John was also there at the first series to launch it. Thank you, John. Catherine Bobenhausen, who's sitting there next to Wendy on your left, is a certified industrial hygienist and senior consultant with the health, safety, and environmental firm of Colden Corporation. She is an AIA Fellow, an authorized green screen practitioner for chemical hazard assessment, a certified safety professional, and a LEED BD and C accredited professional. At Colden, Catherine is engaged in a variety of environmental health and safety and sustainable design material health consulting services, working with manufacturers, architects, and sustainability consultants. We're also very grateful for Heather Henriksen coming today, a good friend of ours since the beginning of our grant. Welcome, Heather. She's served as Harvard University's Chief Sustainability Officer since 2008, advising the president of Harvard and senior leadership on strategy and building an organizational change initiative that resulted in the university community achieving its initial science-based climate goal of a 30% reduction in net greenhouse gas emissions from 2006 to 2016. Congratulations, what an amazing feat. A nationally recognized leader in healthier building materials, Heather is leading an effort within Harvard and externally with business and nonprofit leaders, including Google and the Healthy Building Network, to address the use of chemicals of concern in common building materials and products. And she serves with me and with Wendy on the board of directors of the Health Product Declaration Collaborative. And lastly, at the end here, my colleague and friend, John Sarah Ruth, Design Director of the Healthy Materials Lab and Associate Professor at Parsons School of Design, and Founding Director of the MFA Interior Design Program. As director of that program, she led the Aftertaste Initiative, a symposium that brings new definition to the field of interiors. Central to her work is listening to and learning from diverse perspectives, and studying human experience, behavior, and health as principal motivations for design. Material curiosities drive her research. She's a designer and artist and founded Salty Labs, a collaborative design studio to improve environmental health while creating viscerally designed spaces, events, and furniture. She also was invested early on in the design of furniture for children. Her Q Collection Junior, she designed the world's first Green Guard certified crib for children. And then finally, Wendy Vittori and myself. Wendy Vittori is Executive Director of the Health Product Declaration Collaborative, a not-for-profit member organization committed to transparency, openness, and innovation in building products. Prior to assuming this position in May 2015, Wendy has served as a leader in business, academic, and civic contributions for over 30 years. Beginning her career as a software engineer, she led technology businesses at both Intel Corporation and Motorola. And I am Paula Simias, Assistant Professor, Director, and Director of the Healthy Materials Lab at Parsons. I'm co-principal investigator of the Healthy Affordable Materials Project. The project is a coalition of 4 organizations, including HPDC, who work together to incorporate human health as criteria for evaluating building products to improve the interior environments of affordable housing. And we were just refunded in May this year for another 3 years. I think Wendy would like to give a little introduction to the subject today, the topic today.
Thank you very much, Allison. I want to thank all of you who are with us, both live and on our live stream. Parsons and HPD Collaborative have partnered together to bring you this series of discussions. The first 3 are really aimed at the architecture and design community to help inform the next steps. So once you decide that you want to incorporate transparency and material health into your practices in your firm, what can you actually do? How do you actually go about doing this? So this is a next level of discussions that we are so fortunate to have experts and leaders in these practices sharing their experiences with you. So what you're going to be hearing about are the real experiences of practitioners who are leading this field. And we hope that this will really inspire all of you to find out more, take the next steps. The content from this series is going to be formulated into an online course that will complement the first introductory course that we offer from HPDC, which is just really about getting started and learning about this, and also an extensive series of online courses that's been developed here at Parsons, as well as other resources that are available to you, a growing number of them. And we'll give you some information about that at the end of the session. Tonight's session is going to focus on the issue of how to actually use the material that is contained in reports such as the Health Product Declaration, or Declare label, or a C2C certification, or any other of these assessments and certifications that have been developed that provide an architect and designer with information about the chemical contents of a product and the associated health hazards. And so the first step is obviously gathering this information and having it available and understanding what the different elements that are reported are. What we're going to be addressing tonight is once you've taken that step, how do you start to use this information to identify products that have preferred health characteristics based on criteria that you've established? And we're going to hear examples of how to establish criteria in firms and at Harvard, for example. How do I assess this information? How do we train our people to really work with something that an architect and designer didn't learn in school? Now, part of our plan is to help people at schools such as Parsons learn more about it. And fortunately here, if you're a student, you are beginning to learn much more about all of this. But we want to share this information much more broadly. So that's tonight's topic. I've gotten to the level of understanding transparency reports. How do I move beyond that to actually deal with what we call material health information? So without further ado, I'm going to introduce John Sarah Ruth, who's going to give us kind of an overview of how you might approach this topic area. John Sarah?
Thanks, Wendy. It's a great beginning. Yeah, so that's me. So I thought that I would do today is just kind of give you a brief summary of how we bring this into practice, bring this kind of material health thinking into practice. Because really, it is a way of thinking, material health. It's a way of thinking. So it can be incorporated into design practice, but it's kind of a philosophical shift in a way. The way we do it is asking questions. Really, that's the basis of the whole premise. as designers and architects, we are trained to ask questions all the time. That's how we get to bigger ideas. That's how we get to innovation. It's the Socratic way. That's what we do, we ask questions. But it's a new practice for designers and architects to ask material health questions, which sometimes involve, as we know, chemical and scientific and chemical and health sciences. So I thought what I would do just now is just start by listing these questions that are kind of ingrained as we train students to think. We know that there's imperfect knowledge in terms of the answers, but this practice will get us closer to healthier design decisions. And there's a lot of complexity here, which we'll all hear about, I think, tonight. And so this is maybe a simple way to start to break down how we get into these practices. Anyway, so I'll just start. First question, what is it made of? This is the number one question. What's the material contain? This is why we have these kinds of reports. This is why HPDs exist. We need to know what's inside. And we go to these reports and we'll see with my colleagues here, these experts who are implementing them, how we use these reports. The HPD, the declare label, internationally the EPD label, and if we can't find anything else, the required safety data sheet. And in that, we would ask not only what are the ingredients, but what are the percentage of each ingredient? And what is a harmful amount of that ingredient? It's very simple if we think in terms of food thinking. Food thinking is way ahead of us. Food thinking is way ahead of material thinking because we know that we are what we eat. At least a lot of us know that. We are what we eat. I grew up with that kind of motto in my household. But we don't always grow up with knowing that we are also where we live. And so we know that many people are accustomed to looking at the ingredients label of their food before eating it, so that they know, when I eat these Doritos, I know that becomes part of my bodily system. What we don't really need to know, and what we need to make a habit of knowing, is that what our materials are made of also become part of our bodies. Second question, how is it made? And this gives us great insights. So if we think about where things come from, even now, a cotton picker in some parts of the world might spend 8 to 10 hours in the fields that are laden with pesticides. So the question is, how is it made, is followed by, where do the raw materials come from? Where in the world do they come from? And are the people who harvest those materials exposed to the hazardous substances? Is the environment affected by these harmful substances during their extraction? So it's a constant inquiry. It's a curiosity. Are there any harmful substances needed to manufacture the product? Once we extract, do we need substances to manufacture? And when they are disposed, those substances, will the environment be polluted with those substances too? Are the people who manufacture exposed to hazardous substances while they're working? So again, it's a list of questions, and as we ask these questions, we get answers. Third question, where is it made? This has many implications. Ships burn a lot of fuel. In 2012, they ended up emitting more than 796 million tons of carbon dioxide. And the Panama Canal currently is undergoing an expansion to handle the next generation of large container ships. Which means our design decisions, where we ship things from, actually have an effect on the atmosphere, on the geology of our planet, and on the changing climate of our planet, and ultimately on our health. This is a map, actually, that's kind of beautiful. You can find it at shipmap.org, but it's put together by the UCL Energy Institute in London, visualizing shipping data. And according to the study, more than 11 billion tons of stuff gets carried around the world by large ships each year. So the question is, does the material require long-distance freight to get it to the site? Or is there a viable local alternative? Can we find and use materials and products that are sourced locally? 4, does it require finishes? Are additives needed? Is a material sufficient as it is? Or does it absolutely require further additives and finishes? And I think we're going to hear more from Harvard about this, because I've always been impressed with Heather with your story about this. But if so, what are the finishes made of? And are those substances safe for people? Does it need an unhealthy, durable finish? An example is polyfluorinated chemicals, or PFOAs, which are used to achieve water and stain repellents. And that's what this is showing, is a repellency of water or stain. These chemicals are associated with kidney and testicular cancer, elevated cholesterol, thyroid problems, decreased fertility, and many more things. Arlene Bloom of Green Science Policy Institute, in her 6 classes work, implores designers to ask, is it absolutely necessary to require water and stain repellents? Do we really need them? And does it absolutely need to be repellent? Or can we change our behaviors or our expectations? Can we wash things instead? How can a material or product be made to resist water without using finishes? And this is where I kind of get excited, because this is a prompt for designers. Like, how can we make something that doesn't need to have an additive in order to give it repellency? This is what we're looking at. You can see that the water is jumping off of this fabric. This is a fabric that I found through Textile Hive, which is an archival library of textiles. And this is a textile from Japan that's a very tightly woven silk that was used historically as raincoat material. So what can we use in terms of a weaving technology and a material that is water repellent in its inherent sense? That's very exciting. That's a design idea. 5, how will it be installed? This leads us to a lot of questions. Does it require adhesives? What are the adhesives made from? Who will be exposed to the adhesives in their wet form? Is there an alternative to adhesives? And we have a mantra at the Healthy Materials Lab to say, using fasteners instead of glues is always the better solution. And sometimes eliminating something, like a glue, sparks design innovation. So designing for healthier thinking often means an innovative product. In this case, there's a click floor to create a floating cork floor, which actually also allows for easy disassembly later. 6, once the material is installed, who will be exposed to it? Who are the primary inhabitants? Maybe the place will be inhabited by children with delicate developing organs, or by pregnant mothers feeding developing fetuses, or by older people with more vulnerable immune and bodily systems. Or maybe the place will be inhabited by people who are exposed to hazardous substances all day long in their workplace. Should their homes also contain potentially hazardous substances? Or maybe people who live in fence line communities near constant exterior pollution coming from factories and major highways. Why should their interiors also be polluted? 6, so of the people that we design for, what are the most significant health vulnerabilities of your clients? And so this is an example, and there are so many, but this is just one example, which is that asthma is one of the most common ailments of both children and adults, which is linked to the contents in building products. And this is a thorough list of building products. It's very small. It's hard to see. But it's a thorough list published by Perkins and Will just 2 years ago of common products that we build with that contain asthmagens, chemicals that are known to trigger asthma. Resilient flooring, tile carpeting, interior paint, classroom furniture, audience seating, wood doors, cementitious coatings are some of the few that are listed here on this sheet. So knowing these health triggers, knowing that we want to avoid asthmagens, for instance, can help designers make healthier choices. because there are a lot of great organizations putting out this kind of data. So if we know we want to avoid an asthmagen, we can go to some kind of list and say, maybe we should avoid some of these things. And the final question, which is maybe one of the most commonly asked, which we know about, and actually has been in culture for a while, is where does the material go at the end of its useful life? Are we designing things and places that will end up as waste in the near future? Waste that not only pollutes the environment, but also pollutes our bodies. Orb Media, maybe you've seen some of this, but Orb Media's microplastics reporting, their story is super compelling. On the left is maybe, I don't know if you can make it out, but on the left is a coffee mug with steam. And the steam is showing the microscopic particles because an acrylic blanket has just been shaken in that room. And so these are particles of microplastics, which get into our body through inhalation. On the right is a nano-sized polystyrene particles in the gastrointestinal tract of plankton, which is the baseline of marine food chain. So the fish eat this plankton, we eat the fish, etc. So inevitably, these materials are getting into our bodies through different pathways. But I love these slides from our friends at Carpet Cycle. What if we avoid that waste stream and instead they are collecting used carpet, separating it, shredding it, and making it into acoustical insulation and selling it as a new product? So these are the questions. And these are questions that I ask my students. Every time you select a product, every time you're thinking about materials, you need to start asking questions. And your questions might be different from this list. They might be much longer than this list, but they should include some basic principles. What is it made of? How is it made? Where is it made? Does it require additives or finishes, sealants or adhesives? How will it be installed? Who will be exposed to it? What are those health vulnerabilities of occupants, and where does it go at the end of its useful life? These are the design questions of the 21st century. This is the future. So the idea is that we need to start practicing material questioning every day and incorporate it into everything we do. That's the new design teaching. You have to bookmark trusted resources because this is a complex field. There's all kinds of information out there, and you have to know who to trust and where to go to find this information. Luckily, we're going to hear more from experts about that now. We at the Healthy Materials Lab have collected from trusted resources a lot of this information. On our website, you can go to a place that's called Tools and Guides, and it's organized by topic. So here, you can find material health research, more about health and materials. You can find materials guidance, which is just a general guidance about the most common products used in buildings, and understand what kind of health risks are linked to them. There are databases of certified products, and of course, some of our favorites here, Declare and Cradle to Cradle. And then, of course, collections of databases of third-party certified products and transparency. HPD is right there at the top. And a list of databases of, an explanation of the difference between a certified product and a disclosed product. Because we find actually there's some confusion when people come to this for the first time between those two things. So the question we get all the time when somebody gets through this, and sometimes, we have very smart people looking at this, and so they ask this question within 5 minutes, which is, what are the alternative materials? Just give us a list, and which is a really difficult question, and I think that we're going to hear some from our experts here, because for every situation, it's slightly different. But what I just thought I would show you is just, we have some material collections that are also listed on our website. They're just short lists of materials. One is materials that have been used in healthier buildings. These are primarily from affordable housing. And we're also compiling a list of materials for the future, which is very exciting. these are truly innovative materials that are still in testing phases. They're not completely in production yet, but we do feel it's the future. Alginate is made from sea kelp and algae, and it's a textile that will be used in running shoes. The mycoboard or other kind of mycelium products is made really from mushrooms and agricultural waste as their food to grow into acoustical insulation and other kinds of products. And this is Zoa, which is a leather-like product, which is like a hide that's grown in a petri dish actually, and it comes from collagen and some still proprietary finishes. But it'll be exciting to see how these eventually make their way back into building products. And our final resource, which I think you've heard about from Allison and others in past presentations, is a course that we've developed on material health, which really gives an in-depth perspective on how to understand material health, building chemistry, and then how to implement it for yourselves. And you can find more about that at healthmaterialslab.org/education. Thanks.
Does anyone have any questions for Jansara? We're going to have a discussion period at the end, but if anyone had any burning questions, and Abby, is there anything from the live stream? I'd be happy to take it right now. All right, so let me now introduce John Amatruda, who is going to talk about a framework for answering some of the questions that Jansara has so aptly posed for us. John?
Thank you. That was really a great segue for me for what I would like to talk about tonight, because I'm an architect by training, and I work as a sustainable building consultant, oftentimes now consulting with other architects and owners and developers on issues of sustainability in projects, and including very much in the issue of materials and materials health. And so what I'm going to talk about today, is this how we do it? Yes. I'm going to try to talk a little bit about what our perspective is and my perspective in my office in terms of the work that we're doing to try to use this transparency data to affect choices and to create a process. And I think for us as designers, without the detailed technical training that we hear from Kathy and some others tonight, is really to try to figure out ways of taking this very complex information and finding a way to structure it in a way that's more understandable for designers and also very actionable, which I think is a critical thing in our practice. You know, we want people to be able to make decisions and to make choices. They may not be perfect, but we're trying to move people in a particular direction. So really, you know, I like to show these three sort of slightly corny-looking graphics here, but I always like to bring up the point that really, kind of like Wendy was saying at the beginning, is that, you know, what we're really talking about is kind of expanding, in some respects, this idea of what's the ideal background or education to make these choices. It would be some combination, at least from my experience, of someone who has the designer skills and knows materials and how they're used, someone who has the technical, chemical type of or scientific background to understand how to read some of the data that we're receiving through these types of transparency documents, and also the detective, because I think really there's a lot of open questions, there's a lot of things like Jansara was saying, where you're really trying to figure out how to piece things together and come up with some kind of an actual decision-making process. So talking about process, you know, if I had to very succinctly say, you know, what is the process that we're using, which very much involves the kind of resources that Jansara was talking about and a lot of the questions that she's been mentioning as well, I would simplify it into these kind of 4 basic steps. Because typically what we're finding, you know, in our practice is that the questions that come up are going to be related to those questions that Jansara's asking at the very end about, you know, well, what do I use for this? You know, what should I use for flooring? What should I use for the paint on the walls? And so, you know, what we generally do very quickly is that, you know, we look at what is this available research on a specific material type. And this gets into some of the resources you just saw about things like organizations like Healthy Building Network, EPA, Building Green, other resources out there where people have actually looked at a particular material type like carpets or paints or other products and started to identify what some of the critical issues are related to those products and perhaps very specific chemicals of concern, so that you start to build at least a background of what it is you're starting to look for when you look at that type of materials that you're going to be using in a project. The second thing that we do is to actually look for product-specific data. This is where the health product declarations and the EPDs and the labeling, whether it's cradle to cradle or declare, things like that. These are things that are specific at an individual product from a specific manufacturer, and now you're trying to relate that information with the information you received in general about the material type. Ultimately, using those two types of sources, what we're trying to do is make direct comparisons of products. And when I say establish filters, I'm talking about the idea of looking at things like various red lists, like whether it's from like the Living Building Challenge, whether it's the list of asthmagens, like Sarah was mentioning. Sometimes it could be things like the 6 classes of materials that was also mentioned earlier. Various filters that allow you to actually look at what's in the product, what level of toxicity are we talking about, and how many different places does this particular chemical show up within the products that you're looking at. And then finally, by going through that level of information, what we're trying to do is to ultimately come up with criteria. What is it we're trying to avoid? Are there certain things that we particularly want in a particular product type? And ultimately, also, when we're talking about specific products, potentially actually ranking certain things and being able to say, what do we actually think on a decision-making basis would be preferred over something else. And so what I'm going to talk about more tonight really is what our own process has been in terms of trying to deal with this process and where we think it might ultimately start to go in terms of more of an industry-wide way of looking at this issue as well. So here's an example of some criteria that we use now when we're looking at carpet tiles. And there are various things that you'll see here, from emissions testing to issues related to the type of carpet yarns and the type of recycling programs and the type of installation system. The thing that I would say, specifically to talk about tonight related to issues, let's say for health product declarations and product transparency information, would probably be the chemical content avoidance list, which we have noted there. Now, normally on a project, we'd have this information organized in kind of a specification type language so that it actually defines these criteria in terms of product characteristics. But one of the things that we've also realized going through something like this is once you start identifying the various options that are out there, it's very difficult to kind of come up with a one-size-fits-all type of set of criteria. If you were to take, for instance, all of those chemical content avoidance measures and say they all have to be met for any carpet tile that's going to be used in your project, you'd find that there are going to be issues related to how many products, have you limited the ability to use that can actually meet all these, and I can tell you it's going to be relatively slim these days. There may be issues with availability, with cost. Certainly from a designer's perspective, there's going to be a lot fewer opportunities to use different types of styles or patterns or materials that they might be interested in. So I'm just going to say sort of hold that thought, because one of the things that we've come up with is that in addition to sort of coming up with the criteria, there is this idea that we've been trying to deal with, which is that it's very difficult to say that one specification is going to sort of work for everybody. And this table, it's a little difficult to read, but this represents a different type of study that we were asked to do for a client. And this was an interesting one from my perspective, because a client came to us and said, we have a big building, we have some mechanical rooms, we have to use, or we're planning to use, a liquid applied flooring. Most of these products are made either from epoxies or polyurethanes or other types of very durable materials, but none of which are green, I would say, at all. But the question they asked us was, we have 3 specific products is there any significant difference between these products and how would we actually rank them or evaluate them? And without getting too much into the details, I can tell you if you kind of work your way from left to right here, we had to do some basic, apples to apples type of comparison issues. We had to figure out for each of the products, and by the way, you'll see 2, which is the epoxy, was a two-component product, so we had to look at 2 components. But we had to figure out, what's the coverage, first of all, how much of the material is needed to do the job. Secondly, fortunately, most of these products actually had HPDs and safety data sheets, so we were actually able to look at both the level of toxicity of the different chemical components that were in the products, assessment data. In their data, purple is the highest level of hazard, red is the second highest, and orange is the third, going from urgent to very high to high. And so we looked at those 3 categories of chemicals. We looked at what percentage that represented of the overall product, and ultimately we came up with a hazard quantity per 100 square feet, which was the closest way we could kind of come up with an apples-to-apples comparison. And then really by looking at how much of the most toxic compounds there were, we did identify that there were some significant differences. So product number 1, which was ranked the highest, we actually felt was significantly, would reduce the most harmful chemicals compared to the other 2. Now, from my perspective, this is an imperfect type of analysis, even though it did involve several steps for us. But what it does represent is another issue that I think we found with a lot of products that we're evaluating these days, which is that, there are levels of what we call incremental optimization. That is what we spend most of our time doing. There aren't all that many products that we can pull off the shelf these days that we would say this is a truly green product and it definitely represents the thing you want to use. And so what we realize is that we have to sort of operate right now in this world of trying to define what is the best option within what's available and how can we push certain directions on the products that we're looking at. And so that led us to this sort of moment of thinking about something slightly different, which is we said, okay, we know we're looking at products, we're trying to come up with criteria, specifications, but we want to be able to somehow communicate and figure out a way that might be easier to sort of rank these things and communicate them to people that we're working with so that it's not so much like a table like you saw the last time that we're using, but something that people can relate to from other parts of their lives. So we looked at some examples of other ways that things that most of us are probably familiar with. How do they communicate this kind of complex information? I think most of us have probably seen consumer reports at some point. The Good Guide is something that's specifically more of an environmental type of ranking system for certain types of consumer products. And I realize I'm really dating myself here with Rolling Stone and Michael Jackson. I should have probably put Rotten Tomatoes or something there. But the idea, like when you look at movies or films or things like that, we're used to seeing these ratings that actually take fairly complicated ideas and sort of distill them down to something very simple at the end of the day. And so we were thinking, how can we try to use something like that as a process of approaching material selections and communication? And so what we're working with, this is something that we're working with right now in sort of parallel with our general consulting, which is this idea of creating a ranking system for materials. We sort of have dubbed this right now, this process, the finish line, because what we're doing is we're looking at finished materials in buildings, things that would have the most direct health impact on people, and we're trying to create essentially a ranking system, a kind of line, if you will, on which products perform better than others. And we have sort of 2 different ways that we're looking at this. So when we look at individual materials, and you see the star system, it's a 1 to 5 star system, and we're really trying to, with the goal of really trying to create a way to communicate incremental improvements in products. And then we've also have a second part of this that I'll touch on very briefly, which is like, once you put these products together into an actual building or an actual space, how do you take credit, or how do you communicate to your client or to your users, what you've done? Again, it can get very technical, and that can be very inscrutable for a lot of people. So how can we create a simple system here? We're obviously sort of taking the cue from lead and from well and things like that and saying maybe there's a way to just come up with a series of rankings for overall informed choices. And I'll show you kind of what we have in mind for these things or how we've been working with this. So I'm going to use the example of pre-finished wood flooring as a basis of just running through these next few slides. But what I wanted to start out with was this idea, as I mentioned, that we've been doing a lot of work on trying to create these specification criteria for things like I showed for, say, carpet, or in this case, wood floors. And what we realized was, since that one size doesn't fit all, we have to kind of blow up those spec criteria a little bit, and then start to sort of put them back together again over a range, to create a range, to create a landscape, if you will, of better or good to better to best. And so within this 1 to 5 star system, we basically, had to start out with the idea of how do we create our bookends. Our bookends have to be, what's the minimum criteria that we think deserves recognition for a particular product type in terms of improvement. And then on the 5-star end, what is the ideal? What would we ultimately like to see as the performance criteria for this product that we're looking at. Another really key issue that came up as we were looking at this, and that comes up all the time when we're looking at products, and I think you'll hear others mention this as well, is that we decided that there really needs to be 2 parallel tracks when you're ranking the product. The first one, which is actually item number 2 on my list, is performance. It's probably the one that most people would identify right away, right? Which is, what are the chemicals in the product? How does it perform, in terms of these screenings and filters? But really, in addition to that, we felt it's really important to also address the issue of the level of disclosure that the manufacturer has provided for these products. In part because having more information ultimately, as you've seen and as I'm sure you'll see with others, it levels the playing field, it makes it apples to apples comparisons, and the more data you have, the better overall you're going to be able to understand that product performs in terms of having that type of information. So we tried to put these 2 things together and ultimately create this kind of ranking scale. So in the case of pre-finished wood flooring, these are our bookends that we use as an example. And these to make it fit on the screen, I've had to kind of really, just put the few basic words to represent the criteria. But I just want to run through this relatively quickly. If you look at the 1-star level, what we basically said is that at the minimum disclosure level we define has to be an up-to-date safety data sheet. And in addition, we provide a couple of different options, one of which is definitely an HPD. The HPD at that point can be either at 10,000 parts per million or 1,000 parts per million. We have a couple of other options we've defined if the manufacturer really hasn't provided an HPD yet, but has other credible information related to disclosure. And then when we look at performance criteria, just, again, for this example of wood flooring, we start with some basic things. The emissions criteria, there has to be an emissions test on the product, and it has to be at least as good as what the criteria in LEED version 4 has, in terms of, the criteria it has to meet. We define other criteria for solid wood treatments. If it's a solid wood floor, there are certain things like preservatives or anti-sap stain treatments that we prohibit. If the wood flooring is an engineered floor and uses composite wood, we use the LEED V4 basis of either ultra-low emitting formaldehyde or no added formaldehyde as a basis. We have some criteria for applied backings. A lot of these products have acoustical backings that are laminated to the bottom of it, some of which are made out of PVC or can be made out of foam or recycled rubber. Those are prohibited. And then also even the top coats, we're saying, at a minimum, no PVC. Some of the very high wear products occasionally will have an offering for PVC coating on them. Now at the other end, as an example, it's actually almost slightly easier to define the 5-star criteria. Because in a way, what we're doing is we're saying on the disclosure side, we're using essentially what right now is probably about the highest level of reporting that is asked for HPDs, which is at 100 parts per million, a nested analysis if the nesting is relevant to the product type, and then it has to be third-party verified. From the emissions testing, it's similar to the initial, but it's more stringent in the sense that the residential scenario for the emissions test is the most stringent test that it would have to pass, and we're saying whether it's used residential or not, it would have to meet that criteria. And also there's a TVOC limit for the emissions test as well. And then when it comes to the chemical content part of it, what we're trying to do is to integrate these other systems that are already out there that are more, I would say, ideal based. So we're looking at cradle to cradle gold or better. We're looking at declare red list free. We're looking at a third party verified product with no benchmark 1 hazards. And so you can kind of see that you go from some very tangible things there to some very idealistic things here, which, by the way, we have not found a wood flooring that meets our 5-star criteria yet. But it doesn't change the fact that there should be a 5-star criteria, that's what we want a manufacturer to understand. And then, of course, once we have the 2 bookmarks, or bookends, now we have an ability to kind of fill in incremental steps between 1-star and 5-star. And in fact, what you start to see here is there's a certain amount of repetition that works its way through. I'm not going to go through these each individually, but there is a certain amount of repetition. There's a certain amount of incremental stringency that applies to some of these characteristics. And then there are additional characteristics that start to be added as you work your way through the system. So really the idea is that this could be done theoretically for many material types, and we're trying again to focus on major finished products like wallboard, paints, carpets, wood flooring, cabinetry, things of that nature. And one of the reasons we're trying to propose and communicate a system like this to others is that we think that there are certain benefits of structuring something like this. Number one is obviously if you're a designer, there are different levels that now you can decide that you want to go into with this system. You can stay at the star level and be right there and say, I want a 3-star or 4-star product. That's all I need to know. And that's all I need to know to make a decision. However, the point of this system is that the criteria can theoretically be as detailed as it needs to be. And the whole point is that it should be robust, so that behind those simple criteria is a very flexible system to allow all kinds of things to be stated that then the manufacturers and others can actually use to compare against those criteria. The fact that it is a criteria-based system means that it can function not only as a basis for writing a specification if you need to, but again, it allows it to be used by multiple users. So if you're a consultant like us, we can use it. If you're an architect, you can potentially use it. If you're a manufacturer, you can potentially use it to look at products and say, what level does this product meet? Other critical things, of course, incremental. We're trying to get broad participation from manufacturers. I think one of the things that we've noted is that Lead V4 in its current incarnation, really sort of missed the boat a little bit on the optimization credits. They made them so difficult that they're almost impossible to use. So how is that influencing the manufacturers and encouraging them to do something? So we think there needs to be a way for manufacturers to feel like they can potentially participate, and some of their products can make it in, even if a lot of them can't. At least some of them potentially can, and it certainly gives them direction on where they should go as well. And the last couple of things, no negative ratings. The idea is that even at the 1-star level, you are above a typical industry standard, even above what LEED requires right now. And then also, obviously, as I spoke about at the end, we're trying to incorporate other industry standards. So if you're sort of confused about how do I use cradle to cradle and declare and all of these other mindful materials, how do I use all these things in a way to ultimately make decisions, we're trying to sort of bring that together in a certain way. And then finally, very quickly, this idea that, okay, now once you've established a set of criteria for materials, again, most people, we've worked with some developers who have done an incredible job about reviewing materials in buildings like, say, a residential building, multifamily residential, but even they have a very difficult time communicating to the users. What did we do? How do we explain what we did and how it was better? And so again, we're trying to sort of piggyback off of that lead well idea and say, well, what we want to do is to create a way to rate it. And so I know this spreadsheet's going to be impossible for you to read. I apologize for that. But what I'm trying to show is a little snippet of kind of the way we were approaching this. And the basic concept behind this is really pretty simple. You look at the finishes in a building. Again, we call this the finish line, so it's about finishes. we look at various categories in the various rooms. So if you were looking at an apartment, you can see there's a floor, ceiling, walls, cabinets, other things that would show up as major finishes. They get broken down into individual material types. Each of those material types in this red box you see has a ranking through that 5-star system. Now ultimately what we've realized is there are certain weightings that we feel like have to go into that to ultimately make a certain level the playing field a little bit. But the idea is essentially you have a quantity takeoff of the surface area of these different materials. You have a ranking for the material. You multiply those things together and you have ultimately a system of point totals at the end that defines levels for certified silver, gold, and platinum. And based on the types of materials you use, the major materials obviously, or I shouldn't say maybe obviously, but the major materials would in this system get more weighting than things that are only used in very small quantities. But the idea is that you could put this thing together and ultimately come back with an assessment that says, we've achieved essentially a gold rating in terms of the level of healthy materials usage that we've applied to this project. Now, one thing Wendy asked us to talk about quickly was, what do we think would really help for the future, the near future? From my perspective, given the process that I've been talking about tonight, the first thing I think would be a way of automating comparisons of HPDs, which I don't think is really much of a stretch ultimately once the right people get at this. What we would love to see is, if you go back to that liquid flooring assessment that we did, we'd love to see an ability for us to go in and say, I'm looking at a specific set of products that I want to compare, and I want the program to tell me, what are the various chemicals that are in this product, rank them by hazard level, and tell me what the quantity is of each of those chemicals at these hazard levels. If that was done automatically as opposed to being done manually, that would be a huge help in terms of being able to start to make these rankings of these different products. And then also the ability to, again, say, I want to compare these products against, 3 or 4 different red lists. I want to compare it against the list of asthmagens. I want to compare it against the Living Building Challenge red list. If it can do that, that's going to, again, be a big time saver in terms of the ability to be able to start to look at things and make some initial comparisons. And then finally, development of resources and tools and processes. I presented what we're trying to do. May not be the only answer by any means. Others may have similar ideas that would be accomplish the same thing. But what we really think is that ultimately the idea of consolidating information about products and simplifying it in a system that again allows designers to take real concrete actions in a way that doesn't necessarily mean they have to become chemists and experts and detectives, private eyes at the same time. That, I think, will lead to greater adoption, and that's ultimately what we're hoping is going to happen. Thank you.
Thank you so much, John, for sharing that very, very interesting methodology with us. And so we're going to hear another sort of methodological approach from Catherine Bobenhausen now, who is an industrial hygienist, by her expertise in thinking about how to apply the lessons from the world of industrial hygiene and occupational safety into this management process that we have. So Catherine?
Great. Thank you. It was really pretty amazing to hear both Sarah and John this evening, and I hope to share a little bit from my perspective as an industrial hygienist. As you may know, the American Institute of Architects put together a white paper on material transparency, and one of the questions was, should architects become health professionals? Or is there liability when you start to get documents that have chemical information in them? And so in their transparency document, it says if the client has goals different from rating systems or ways that an architect could understand how to rank, then the owner should contract directly with health consultants to clearly define goals, set priorities, and provide advice about merits. you can understand these are corporate attorneys within the architectural profession, and they're saying it's best to not subcontract someone in the health field, but more have an owner's rep who represents that interest on the part of the owner. And so what is and so I mentioned in this first slide that the CIHs work with contractors, they evaluate risk to installers, they do some in-field testing, and they're alert to occupational safety and health warnings in industry. Many people don't know what a CIH is. I'm a CIH. I'm an industrial hygienist, a certified industrial hygienist. There's only about 6,600 of them worldwide, and so there aren't many of us. We're like detectives in the workplace. John had mentioned that detectives are important in this field, and that's what we are. We're an accredited profession, meaning that every year we have to indicate that we've maintained accreditation. We do that by publishing, by teaching, by working on professional development. And so when Wendy asked me to speak, she asked me to talk about how an industrial hygienist confronts the same topic, the material health topic, from our perspective. This is kind of the grounding, the foundation for industrial hygiene, meaning that if you can avoid a hazard, that's the best way to solve a problem and make it safer for people. So eliminate the hazard is the best option. If you can't do that, then maybe there's something that's a little less hazardous, substitute. If not, maybe there's something you can do from an engineering perspective, like local exhaust, to get that material away from the person. Administrative controls, if there's no other option, and if somebody has to work with that material, maybe they don't have to work with it all day. So we switch out people. You can see it's becoming less and less effective. We can teach people to cover the can, behaviors, use just as much as you need, those kinds of things. Or at the tail end of this, wear personal protective equipment. So do your work with a respirator, wear that all day, you'll find out it's not very comfortable. And so this is kind of parallel to what you're doing as an architect, which is once you know there's a hazard, what are you doing to solve that problem? What you want to do is eliminate the problem, right? So continuing the questions from John Sarah, how can the lowest hazard ingredients be used without losing high performance? This is something that I was looking at through the Clean Production Action. They've updated their green screen guidance, and they're saying one of the problems is there's such a high bar for performance, and if customers want that high performance, how do we develop materials that are safer and yet perform just as well? John Sarah came up with a good example with the silk being very water repellent, right? But it's not everyday materials that meet that criteria. I remember one time the father of green chemistry, John Warner, saying that people assume you can just open a toolbox and there's less hazardous chemicals in there. We've not yet developed them, we have not yet done all the research that we need to implement them on a full scale. And we find that each ingredient in a formulation normally has a function. So the question is, if those functions are essential, how do we make it less hazardous? When John did his presentation, he was talking about a filtering mechanism, and it came to mind, for me, the green screen for safer chemicals is a really elegant filtering system. You may know of it. It was developed by the Clean Production Action. It was used with the EPA Design for the Environment program, and a lot of different industries have accepted it as a way of ranking chemicals in their procurement. And what it does is it assesses the intrinsic hazards of a chemical. And so it doesn't look at exposure or risk, it looks at the properties of the chemical itself to see if it's a carcinogen, if it's a reproductive toxin, if it's an endocrine disruptor. And it reports what is known and what is not known about the chemical's hazards. So as you go through a green screen, if there's a data gap, the assessor has to say, If this data gap was filled with the worst possible ranking, then what would that do to the overall score of the chemical? And so chemicals are at the core of the materials economy and building blocks of products, and so this is the foundation for the health product declaration. We've adopted green screen for safer chemicals as a real essential part of HPDs. So you may not know when people say, we want a product that doesn't have any green screen benchmark 1 chemicals. What does that mean? It means that it targets chemicals with evidence of carcinogenicity, mutagenicity, reproductive or developmental toxicity, endocrine activity, and those chemicals that are persistent, bioaccumulative, or toxic. There are lots of other different types of health endpoints, but these are the ones that are considered by toxicologists as being the most severe. High hazards for other endpoints such as neurotoxicity and respiratory sensitization receive a benchmark too. So you might say asthma is very important, but in this scoring system, it would not fit within that benchmark 1 criteria. There are 2 different levels which are referenced in Health Product Declaration. One is just the list translator, which is a screening protocol, and it is based on specified lists from state, national, or international governments, like the International Agency for Research on Cancer, the California Proposition 65 list, and so on. And so all of these lists are compiled in a pretty elegant system that was developed with a lot of work by the Healthy Building Network to come up with overall list translator rankings for specific chemicals. If there is not enough information to give a list translator score, or if a client decides to do a more thorough investigation, an assessor can do a green screen assessment, which means you end up looking at the primary literature, the studies that are the basis for the determination of whether it's a carcinogen or not, and figuring out whether those studies are authoritative, they're robust, or if there's uncertainty or there's difficulty in the method. And it also uses analogs and models to assign a hazard level for each endpoint and a confidence level. And so with the green screen assessment, each one of those endpoints gets a ranking, and then there's a logic train to determine what the outcome is in terms of the benchmark. So it's a very elegant system, and I'm glad that it's so integrated into Health Product Declaration. So when I was putting together this presentation, I was thinking, well, what are the most problematic chemicals? And for me, they're the ones that are going to be most problematic, troublesome in an interior environment. So ones that can cause damage that can't be repaired. For example, when John Sarah was talking about working to design a space for mothers, some of those chemicals may be taken up and not only affect her, but affect her fetus and affect them over the entire life of their entire life. And so those are considered very difficult problems. Anything that breaks loose and disperses, and both John, Sarah, and John mentioned those. Anything that reacts with other chemicals to form noxious chemicals, and I'm going to be talking a little bit about that later. As John Sarah mentioned, anything that burdens upstream or downstream communities disproportionately, and we find that with the global economy now. Anything that requires harsh chemicals or treatments to maintain, and anything that's noxious during manufacturing or installation. So these are the kinds of things that I think, without a doubt, all of us are talking about as being priority targets for design teams to be concerned about. Okay, so what can I offer in terms of the types of information that maybe I'm more familiar with, but if I could just show you what happens inside a lab and then what you could look for when you look at documents. So this is at Berkeley Analytical out in California. They put together a lot of the methodology for for doing emissions chamber testing. So they have these stainless steel chambers, and you see on the left there, he's preparing a sample of paint on a metal substrate, and then that paint is going into one of those chambers where there's conditioned air, it's conditioned for a period of time, and then air samples are taken to see what emitted from that material. And so then after the results are obtained, the laboratory, for example, Berkeley Analytical, does some modeling. And John had mentioned the residential exposure scenario being the most stringent. These are set in stone in the standard method. So there's a standard parameters for school classroom, there's one for private office, and then there's a residential. And so they present the emissions not just as what happened in the chamber, but what would happen in your finished space. And so what they do is they take, as a criterion, half of the chronic non-carcinogenic ambient air concentration that's established in the state of California, half meaning there might be other contributors in that space to the overall concentration. So for the individual volatile organic compounds of concern, this is compliant for the school classroom and the private office. They would have to pay probably extra for the residential scenario, so maybe they didn't do it. We ran into that a few times. And then the product coverage, John mentioned in his presentation about that ranking of those different products where he showed the product coverage. So the manufacturer works with the lab and says this is the amount of paint on a surface area that is usually recommended by the manufacturer. So they replicate that in the lab so that the results are representative. So what you should look for is, well, first of all, this is to see if it was compliant. And also there's the formaldehyde limit, which is very low right now. It's 9 micrograms per cubic meter, which is almost at the level of what you normally find in indoor air. And then the TVOC number, the total volatile organic compound number. John mentioned this earlier, as this is a very low number. It's less than or equal to 0.5 milligrams per cubic meter. And you can see the range is, anyway, there are 3 levels that it actually came from Lee version 4, right? That criteria, the TVOC reporting. And so what they say is it's either really low emitting as less than 0.5 milligrams per cubic meter, medium as greater than 0.5 to 4.9, or high as greater than or equal to 5 milligrams per cubic meter. And we found that when I was working with John in evaluating and comparing different products, that was a good indicator of the just apparent difference between a couple of different products. So we've come a long way from when we were just concerned about what was in the paint. I think we're all aware of low VOC paints, but there's a different way of looking at things, which was really highlighted by Lee version 4, which is what happens when the paint cures and dries in the building, what comes off of it. And so that's what we're talking about when we're talking about emissions. This happens to be a facility in Europe, where there's a lab that does that kind of work there. There are very few laboratories that do this kind of work. And so they use an instrument called a gas chromatograph mass spectrometer. And normally what you do is you collect samples on sorbent tubes that contain different beds of material that will trap different types of, or absorb different chemicals on them for analysis for VOCs. So just to get back to Lee version 4 a little bit, there's 35 chemicals that are included in the standard method, but you see the toxicity ranges quite markedly from very potent to less potent, and so it's a good indicator at present on volatile organic compounds emitted. I mentioned that industrial hygienists are also having to be alert to things that happen in the field. Well, a few years ago, the National Institute for Occupational Safety and Health noticed that there were some engineered countertop manufacturing locations where it had gotten so bad in terms of silicosis that some of the employees were going for lung transplants. And so that made them very aware of the hazard associated with engineered countertops. The problem is that engineered countertops normally contain about 80 to 90% silica, which is not a problem when it's a countertop, when it's a solid object. But when you're manufacturing it, or for example, when you're installing it in an apartment, that's when it can generate, by grinding it, you can liberate fine dust, and that can be a problem that can lead to inability to breathe. And so one of my colleagues, who's an attorney, had written an article in the National Law Review, and she said, a high and real concern is silicosis from working with engineered countertops. And she said in project documents, one should require installation guidelines to minimize dust. You can use wet methods, and you can use, there's shrouded equipment, meaning that there's a HEPA vacuum on the equipment itself, so that when you grind, it pulls, it's a little vacuum that pulls, and there's a HEPA filter in it, HEPA meaning very high efficiency particulate arrestants filter on it to capture any kind of silica that might be generated. And so there are European standards, and she mentions that architects in their specs should look at those, and those are industry endorsed. And then the NIOSH and OSHA alert also has more information on that. And so we actually did get into this, looking at different types of countertops. And not only we were looking at the product, but we were also looking at the installer's guide and the installer's training to see if they had really paid attention to this issue. And so it's along the lines of what John Sarah was saying, just ask questions, and some of the answers that rise to the surface make you aware that you are really onto something important, that this is not something to be it's not a game. It's an important exercise to really be very attentive to what's going on out there. What happens if the materials burn? Here's an occasion where I was looking at combustion byproducts, and so in the situation where insulation is burning, it can put off different things. And originally, you heard Amanda Kaminsky speak in the first session. We were working with some firefighters who are very concerned about combustion byproducts, and saying that in their work situation they have a very difficult time seeing inside a burning building because of the number of synthetic materials that are in there, which makes it extremely hard for them to rescue people, and also they're concerned about their exposures on their gear. Not that they're not protected with breathing air, but the materials get embedded into their gear and they can get exposed that way. So I talked to you about some chemistry that happens in indoor air. So you can't just think of your materials as being objects. They're really players in your space. And so you could have, for example, an air freshener, and in the presence of, let's say there's a lot of smog outside, ozone, the air freshener, maybe it's got some kind of pine oil in it with ozone, can form formaldehyde, acrolein, which is very irritating, and ultrafine particles, which can get into the lower part of your respiratory tract. So there's a lot of things that are happening in the indoor environment, and a lot of reasons to simplify your design choices. Okay, so luckily we have the Federal Trade Commission, and they have been attentive to looking at misleading claims. And so we find that sometimes manufacturers, sales departments get a little bit out of line in terms of what their claims are. And so recently, some of the more well-regarded paint manufacturers were were chastised for making claims about their products, saying that they were safe for babies and other sensitive populations. And so it's really important to be aware that there are protections for the consumer, but we still have to really be vigilant and be attentive to those kinds of warnings. We get involved in looking at installation glitches. For example, this is a laboratory in Cinnaminson, New Jersey, where they are taking headspace from spray foam insulation to see what went awry when it was installed. And so that's the kind of work that industrial hygiene gets involved in. And I just came across, in preparing for this talk, this is a really interesting paper, which is a compilation of all the unpublished industrial hygiene studies related to the evaluation of emissions of spray polyurethane foam insulation. It's unusual to see papers that were, work that was put together for a client to be all gathered together and reported as one. It's very interesting, and it says that during installation of spray foam insulation, respirators, supplied air should be worn, and the concern is isocyanates because they're respiratory sensitizers. So it's very interesting. I guess the bottom line is we have to be continually vigilant, but I think that through the good work of Health Product Declaration Collaborative and the Healthy Materials Lab here, Healthy Building Network, a lot of foundation has been built to be able to have more and more people that are informed and able to ask questions in this realm. And I just wanted to leave you with this photograph from a class that I taught with Allison and John Sarah, and there's Bill Walsh and Tom Lent, where we did some actual testing from their materials library to see what was emitted from the different types of products. And we found that each one of them had at least something going on in that jar. So, thank you.
So, are there any burning questions? Abby, do we have anything on the live stream? Okay, in the interest of time, I'm going to turn to Heather as our final panelist, who's going to tell us about the interesting approach that's being used at Harvard University to address a lot of what we've just heard about.
Great. I think what we've heard is we need all these people, and so it is complicated, but hopefully we're trying to help simplify things with health and built environment. I'll just start by saying I think this is important that what we're really trying to do at Harvard on this work is to translate research and science into practice, make it simple and easy and scalable. And I think that's what everyone aligned on this panel is trying to do. And I'll just say that we have a sustainable development grounded vision, but our priorities are really simply about climate and health in many ways. So for instance, you mentioned, Allison, our old climate goal, which we met in 2016. Our new ones are fossil fuel free by 2050 and fossil fuel neutral by 2026. And the reason for fossil fuel, not carbon, is health. We don't want to have an unintended consequence where we fix carbon, but actually potentially could increase PM 2.5 and SOx and NOx and other things in the air. So we want to look at climate holistically. And I just bring that up because it's also sort of our approach in the built environment. How do we look at it holistically so we don't have unintended consequences? So I'll start just by saying, our researchers keep saying we're ignoring the 90%. And that is the fact that we all spend 90% of our time indoors. It's a frightening statistic. I think for large, Harvard's the size of currently Google from a square footage perspective, 27 million square feet. About 45,000 people, 12 schools run independently of each other. So it's a really good test bed. But large companies are asking this, and increasingly, 90% of the cost are the people in your building, and having them be healthy and productive, even to move that needle, we know from our researchers a little bit, adds enormous amounts of money, and we're chasing the 10% in the operating costs. So I think this is a reframe. We're trying to reframe things and the ROI around health. Our folks, particularly at the Healthy Buildings program at the School of Public Health, talk about health product indicators, not KPIs. So this was the wake-up call for certainly me in our office, I think, in about 2013, that there, you may know this, but there are about 80,000 man-made chemicals in industrial use in the United States. I think what, again, we're all trying to address is this is the amount that have any health data at all, about 15%. Any health data, not conclusive health data, by the way, either. And from a federal perspective, guess how many of these chemicals of the 80,000 are actually regulated? Want to guess what that little red dot is? Catherine, you can't answer, you probably know. 9. So that made me say, oh my gosh, just like the food labels, we've all had to become nutritionists to understand a food label. Now we all have to understand this, because this is in our everyday lives. And it's not just commercial building products, it's also in your outdoor gear jackets, and it's in shampoos and lotions and other things these chemicals are concerned. But we'll, at the moment, stick to what we can do in the built environment. So at Harvard, I think one of the most impactful things on our senior leadership has been we certainly can't ignore the science of our own scientists. And other scientists, quite frankly. This science is not just being done at Harvard. And this is a 40-year, 50-year research project where there has been lots of research about what the impacts of these chemicals of concern are on public health. And it's been over here, and then we are, over here buying all these things with chemicals in them. I think the other thing is there's a more widespread recognition of the problem. Nick Kristof, for instance, wrote about 12 to 20 really toxic chemicals that were at least present in his body by doing his own urinalysis. Of course, our office has done this because that's what we do for fun. We test our chemical levels in our bodies. And just these are basically really two big lawsuits. So about in the last year, this is about $1.5 billion has been spent just on the PFAS chemicals. This is this class of the stain and water treatments, which our researchers are saying are some of the worst of the worst. So just, again, this is not something abstract. This is happening in reality. The lawsuit that caused DuPont to rename themselves, look, they come back, Chemours. 37 people died, 3,700 people in class action lawsuit. Testicular, kidney cancer, other things. So this is lovely. This is the carbon-fluorine bond, these PFAS chemicals. I won't give you a big chemistry lesson, other than to say what has sort of been phased out by industry was C8. Guess what they use now? C6, C4, C2. Does that sound good? And this stuff's in everything. Teflon pans, apparel, furniture, as we know, glasses, your car is filled with it, paint can have it, again, outdoor gear jackets, and Scotch Guard. So I think, again, the point is this stuff is a lot of places. The last thing I'll say, not to terrify you, but is, so if you think that, again, these upstream problems with these lawsuits are what's happening, you think those are isolated if you don't live in the Ohio or on the Ohio-West Virginia border where this happened, you're okay. But our researchers have actually pushed the federal government. They released studies saying that if we actually lowered the level of allowable amounts of these chemicals in drinking water, we would go to probably about 6 million people in the United States having toxic levels to about 25 to 30% of the United States in their drinking water levels. And these smaller chains that they're now introducing and using as safe chemistry are not able to be filtered out in water filtration. So this is a problem for everybody, no matter where you live, is my point, I think, on that, and I won't give you any more chemistry. That was just one class. But essentially, this is what we, as a large owner at Harvard, feel that we are buying. John Sarah also mentioned nutrition labels. So would you buy undisclosed proprietary and feed that to your cat or your dog or, God forbid, your child? That's what we're doing with these products. And spending hundreds of millions of dollars a year for something that we could potentially have to remediate later. So that does not feel good for us. The other thing, and I stole this from Dr. Allen, who also did these chemical tests, is there's this concept that our researchers have talked about, Dr. Allen in particular, chemical whack-a-mole. So I'll just spend a second. So these are his results, and mine were exactly the same, so I stole his slide. BPA, look, I'm way down at the bottom, so I am BPA free. Isn't that exciting? So what do you think? Think that they just got rid of all the bisphenols? What do you think that the replacement in that Nalgene water bottle, not to pick on Nalgene, any, most plastic bottles, what do you think that is? Baby cups, sippy cups, plates? It is BPS, 95th percentile. And now that's getting a bad rap, so our researchers think BPF is next, and we're way down here at the end, and we'll be up here, and this will then slide that way. So this is just, they call it regrettable substitution, but one thing that is known to be harmful to health goes out, like on a red list, and another comes in that your body sees exactly, our researchers say, in a similar fashion, and they just don't know as much to know what the health outcomes are. They could be worse. So what's the solution now that we're depressed? Here's some examples. We have more than 6, but if you start to take 80,000, distill it down to 6, which is a concept actually that Arlene Bloom, the Green Science Policy Institute, talks about. And our researchers, and I think there's consensus around the research community, the classes of chemicals, whether they're 6 or how they define them, are the right approach. And so we've really been focusing on, can we start to send a market signal to manufacturers and work with them closely on product categories to get these things out, at least these top 3. Because right now, you could, it's not just the halogenated flame retardants, it's all the chemical flame retardants, our researchers say. These are the PFAS, PFOA, they have lots of names, polyfluorinated alkyl substances. These are the stain and water treatments, the Scotch guards and those. And then antimicrobial. So if we could just get those 3 out, you make a huge dent. And that has been part of our strategy, along with, I think, our biggest impact will probably be providing the latest scientists to people creating rankings and to creating the standards. We don't want to be in the standards business, but we want to inform the science and have them be class-based. So I think, we've been focusing on products and saying, can we work with manufacturers just to get these 3 out? And then because they don't impact the look or feel, and we don't think they impact the function of the product. We beg to differ that these stain and water treatments add anything from a performance perspective, and we're actually studying it as we speak. So that's sort of one approach. Again, these are some of the lovely, John Sarah also mentioned this in the other panelists. These are these health impacts of these chemicals. So, I don't think any of us wants to propagate cancer or infertility or autoimmune diseases. So this is, again, our solution. We created this Healthier Building Materials Academy. It's a partnership with our office and then researchers from 3 schools, the Chan School of Public Health, the Harvard Medical School, and the John Paulson School of Engineering and Applied Sciences at Harvard. And we have a pretty simple approach. Demand transparency, which is, we've been demanding HPD since 2014 on all of our capital projects, 2 years before LEED even was in place, and that was, you could get points for it. Grounding our decisions in the latest science, and really trying to also, where we can, have third-party standards, but not waiting for those standards to catch up in the science where we think we might be able to do better. And because our ultimate goal is optimization for health, not just for Harvard, but for the global supply chain upstream. These are just some milestones. Again, we began educating folks about 5 years ago. We launched the Academy in 2016. We joined Portico, which a number of us are involved in, Healthy Building Network, we mentioned Google. And then I think the biggest thing is that we started doing capital pilot projects to see what we could do beyond these third-party standards. And in under a year, we had 4 product categories that we had standards where we had, gotten these classes of chemicals removed from products. Carpet, furniture, wall base, and window treatments are 4. And now we're up to 30 major capital projects and a dozen product categories. So just to sort of, I was asked to do, what are your practical, if you're an owner or you're a designer or you're an architect, what do you think you can do? Because even if you're not the owner and you can't demand it yourself, as John has shown, he is representing his clients, and he is bringing to them, solutions. So these are just 6 or 7 ideas that we sort of tell our story. So I think educating your community, these are our Building for Health, our research scientists have actually done these classes of chemicals, and more to come. But there are also a lot of other very accessible external resources, like 6 classes, like the CEH, that have buying guidance and really practical knowledge. You can thank John, Sarah, and Allison that the 6 classes videos are beautiful and appealing as well as scientifically sound. The second thing we did was really map our ecosystem for building materials procurement. Quite daunting when you look at how many people you have to educate and you have to align behind a vision and a set of priorities and requirements. These, I think, really are unique to Harvard, but procurement and planners and stuff do start to map to others. Everyone deals with manufacturers, subcontractors, contractors, architects, designers. So we map that to say, who do we have to get to, who do we have to align, and what piece of the puzzle do they play? We also, as I said, insist on third-party transparency. We require the HPDs since 2014. Again, not popular in 2014 with any architect. But thanks to Wendy and others, much easier to do now. We're really considering, looking at, we talked to manufacturers for third-party verified HPDs to 100 parts per million. And we want that to become the standard. But we also look at other third-party certifications like Declare Cradle. And on the furniture side, Healthier Hospitals, which is actually grounded in science and was created by Healthcare Without Harm, and that is our Harvard standard. We require 100% compliance, not 30%, which is you can get the standard with, for all of our furniture purchases. So we also have been piloting, as I said, in really real time using these standards. And then I think the biggest is we've been partnering as owners, I think, can do really well. And just asking the big furniture manufacturers, can you get these chemicals of concern out? Can you get at least the flame retardants, the antimicrobials, the fluorinated chemicals, PVC, added formaldehyde out of your product? And then we've been working with them. Don't just tell us, put it on your website. I'm actually shocked at how bad they are at marketing these things and not making it easy for designers and architects to find. So we've been really working with them to put it out on their website and make it very clear. And so we're helping add to catalogs for everyone. And we really have also educated and partnered with these different manufacturers, and we're leveraging for our preferred purchasing. I think the other is formalizing your commitment. So we signed a pledge. Harvard is not big on signing pledges. But we signed a pledge. We thought it was really important about the science when chemical flame retardants were no longer required from a regulatory perspective. We signed a pledge saying we'd get them out of our furniture, and we did within 6 months. And then we moved on, as I said, to these larger standards and grounded them on our green building standards, which all capital projects have to use. Because if you don't require it, in my experience, doesn't happen. And then lastly, build networks. So I think we've been really learning from others. So I think, we sort of sit in the middle. We've got our researchers over here on the science side, and we're bridging them with the greater world of owners that care about this. Of course, architects and designers too, but this is an owner slide of large owners we've worked with. And I think that's really important. We also announced a new partnership with Google in May, where we're going to try to have them replicate our playbook and learn from also advancements that they've done. I think the big key thing, and John's getting at this, I think we're all getting at this, is we need to really align and send one market signal. We need to decide what we want to ask the manufacturers for to be fair to them. And we need to create a clear signal that says we don't just want this stuff, we're actually buying it. And so you investing money to change your manufacturing process is actually resulting in dollars back in your pocket. So I think that's really what we want to do, is create these public tools and resources grounded in the latest science, and then really just align. And I think, again, where Harvard plays the biggest role is, informing your ranking, informing all these standards. Again, we'll let the market sort out who are the winners and who, aren't as popular. But I think we want to drive the science. And then we want to be ahead of the standards in saying where the standards maybe you've been using the latest science, or there's BPA out and BPS in, how can we try to work with manufacturers to actually solve that challenge on a product basis? And just 2 quick examples to end with to show I think it's possible. And John, now I'm going to challenge your carpet example. But this is very new. This is our flagship project that we've been working on for several years now. And 100% of the furniture, 3,000 pieces of furniture in this project. It's basically 3 floors of furniture. It's communal space. It's the front door of Harvard. It's a community space. Students, as you can see, hang out and study. So 3,000 pieces of furniture, 22 furniture manufacturers that I and someone on my team personally spoke to. 75% of those 22 manufacturers had never made furniture to the healthy interior standard before. They did it. They did it for no added cost and no impact to schedule. So it can be done. Now, we started, just like you would have any good integrated design process, and set these material goals at the beginning. And then we set specific meetings on materials, specific meetings on furniture, and made it happen. And we had that time to do it, which you do on these large capital projects. And we worked with the local, this is a Hopkins architect, you guys might be interested in that, and Bruno Cott locally, and Bruno Cott was really the ones we worked with. And then 100% of the carpet also targeted without chemicals of concern. So no fluorinated chemical stain treatments, no antimicrobials, no flame retardants at all, no PVC and no flash. And when we started, right, those are the biggies. Again, we also have a strategy to not let perfect be the enemy of the good and chase every single thing. These are the big things.
Yeah.
And when we started 2 years ago, only one, to your point, manufacturer made carpet with an off-the-shelf option to this specification. It was Sean Packroff, to give them some props. And now there are, all the majors basically either can do it or almost can do it. So I think that with one line, now we need to show them the money and they'll make all the lines that way. And then, paint, we also, where we can, these other things I'm talking, by the way, too, that aren't really talked about. Everyone hears about VOCs, and Catherine covered that as well. These chemical flame retardants, the antimicrobials and fluorinated chemicals, are SVOCs. They're semi-volatile organic compounds. And I like to describe them as the gift that keeps on giving. So, eventually, there are other issues Catherine will say on paint after it cures, right, where you have to make sure the particles, but essentially when that sort of new car smell or that paint smell goes out, people stop worrying. But the SVOCs are in that product for the life of the product. So, as you sit down on your couch and you touch it and then you eat your sandwich, those PFAS and flame retardant chemicals are still going in your body for, as we understand, the length of your owning it. So think of that. And Wendy will be happy. We also got 45 brand new HPDs in this project. And then the last example I'll give, and this one started very late in the process, actually. And we worked with Harvard Business School. This is their new auditorium, 1,000-seat auditorium. And I think they're the only auditorium in the world. Granted, it was one seat that they replicated, but it does meet the healthy interior standard. And we also worked with them on acoustical panels and wall base and other materials to make them healthier. And the carpet, actually, we worked with the manufacturer to custom make it, and now they're considering making an off-the-shelf line that doesn't have these chemicals of concern in it, because the process was too late in the game for us to select a different manufacturer. So that's just an example of you can work with the manufacturers and they're interested. I think we're aligned. They don't want to expose their workers or their customers to these chemicals of concern. So I think with that, I will end and we can answer questions.
Thank you very much. I think you would hopefully all agree that there was quite a wealth of information here, a lot of great examples of actual using of this healthy material information on specific projects. So let me just ask if there are any questions from the audience or from the live stream that anybody would like to bring forward, and then we can spend a few minutes just chatting here among the panel. Does anyone have any questions? Yes?
As I start to consider material health, I've been thinking a lot about sort of disrupting chemicals that exist in buildings, like as you do renovations or things like that. And so oftentimes we're talking about like making these choices, and you kind of start at that place where you're like, you're able to make a choice. But when you do have these projects where you're, doing a renovation or whatever, and you have to, remove these toxic materials, like, what kind of concerns are there? Like, we talk about some of the toxics, like, they're always kind of toxic, so is there really like a cost benefit, or, I mean, really, like, at what point are we kind of looking at the whole, like, picture, you know what I mean? It's kind of like a
Great question. Who would like to take a chance at this one?
Well, there are different categories. If you're talking about, for example, taking an industrial space and making it into loft space for residences, then there's, issues of like mercury in the floorboards and that kind of thing. Is that what you're thinking of, or are you thinking more?
I mean, I guess just like broadly, because it sort of just seems like it just becomes like a cycle of like you always have to be concerned, and you're always kind of just thinking. And so like I felt really positive about like, oh, we have all these great new choices, and there's you can start to like research them and understand them better. But then it's like when you start a new project and you're met with like painting all these different things that exist, it's like, well, by starting fresh, you're releasing all these things, and then is that level of harm something that we should really be concerned with, or is it more just about like, let's forge ahead and,
This is really highly related to the issue of recycling, right?
Mm-hmm.
So, because that is something that is, I'll just say, a complicated area, because a lot of times the composition of the products that are existing, we can take some educated guesses at them, and there are ways of sort of thinking about what would be the worst case, maybe looking off of what John said with the 1 star, 5 stars. Oftentimes people will say, well, what would be the worst possibility of this? So you'd have to invest some time and effort to characterize, what is there. I think what you're hearing about here is, as you think about replacing those, ways of trying to identify areas, and I think this is really the growing trend, I think you would all agree, is to pinpoint particular product groupings or particular classes of materials where you can say, I'm going to focus on having the best carpet, because that's an area that's pretty advanced. A lot of the, what we call regrettable substitutions, this would fall into that category where we're putting in something that we think is better, but we're creating problems by removing something that's already there. So, that in a way is sort of a different kind of regrettable substitution. But oftentimes it's like the BPA, BPS, BPF problem. We got rid of BPA, and now we have something that in some cases can actually be a worse thing. And so I think you're really touching on a super important topic. There's a lot of energy going into trying to deal with recycling. The notion of the circular economy is one that's really, really driving that. But I think it probably goes back to the advice that I think we've heard from each and every person. Ask the questions, start by trying to size it up, ask those questions, and then, each of one of these circumstances there's not going to be a one-size-fits-all answer, unfortunately. But any other thoughts on this?
It's just a great question because, as we move into this next era, reuse of existing building stock is really important. You know, so renovation is super important. And so how we address where we, you know, when we remove something, who's exposed to the removal, what's in it, that's, you know, that's essential. And I think Catherine addressed that in a big way. You know, can we eliminate any harm for those people, or do we have to protect people? So there's that point. And then where does it go? That's another huge issue. You know, can it be recycled, or does it need to go into waste? You know, does it really become landfill? But you know, ultimately, that space that's being renovated is going to be inhabited by somebody, and it would be better if it was inhabited and it was a healthier interior. So if you're making the choice, ultimately, the long-term exposure will be in there, and so it's good to get rid of things that are, you know, problematic. But you know, it's always this, you know, this weighing that you're saying, like weighing all of the costs, the health endpoint costs.
There's a whole other field of, you know, historic preservation or preservationists that would probably be relevant to that kind of discussion, right? As to how to treat surfaces to make sure that they are durable and functional over the long term and don't need to be taken apart.
Yeah. I mean, we have a lot of experience with this with asbestos, right?
Yeah.
Because this is the long-term issue with this.
Sometimes it's encapsulated and sometimes it's removed, you know, depending on the exposure. And at the end of the day, you know, there are those kinds of level of issues. I would think that, you know, is it better to encapsulate something than to actually try to remove it? But I would also think at the end of the day, even if you were not thinking in these terms, you're going to have a list of products that you're part of your renovation. So there's still always going to be decisions to be made about what products are going to go in anyway. But some of those other things are more like, I would say, like the designer's, knowledge can really help there too, because again, like your list of saying, you know, the inverted pyramid of, can I avoid this, you know, like what level makes the most sense, I think is a really critical question that you're asking, you know. And it's not all about product selection. Some of it may be about essential design decisions first, and then getting down to the level of products.
Does that get it, what you were asking?
Yeah, it's just like, it becomes like overwhelming. It's just something I kind of like always wanted to ask, just to like see what it was. You know, you start to just think about things and it becomes, you know, like kind of obsessive. It just like leads to something else. And you're like, oh, like what is actually better? And then, you know, the part where you like sort of have to educate others and make them understand as well, like why you're making these choices. And that brings up some of these things. Well, like, you know, isn't it bad to, you know, like release this particular substance, and so it's just something that's come up, and I just.
That's another great point, isn't it? I mean, that's what you're talking about. Like a huge part of this is educating others. I mean, that's what I think you guys have been so great at, really, is to say, come on board. Like, we have this theory, we believe it, and now we need more people on board. You know, meaning like even just your institution, within your institution, to say we're gonna get behind these ideas, and like how you educate others to say, yeah, this is a great idea, come along.
Yeah, we've sat in, well, now over 30 major capital projects meetings with everyone on the entire team, including the architects and the designers at the very beginning, setting those goals, and then spending a couple of hours literally going through like a much more detailed science of why does this matter, what are we going to do, you know. And I think it's a combination, sort of what you were saying is, yeah, there's these things that we're going to do, really focus in with our researchers, and then how are we going to address the rest of the thousands of products in that building, and we have to rely on how good the HPDs are, and the other sort of information from the standards at this point. So I think, you know, again, our motto is, as I said, like, we're trying, don't let perfect be the enemy of the good. Just start somewhere. I think this is your point too with the STAR system. You know, getting transparency is better than something, you know, just sending that market signal for transparency is so important, because maybe only researchers and people like Catherine, industrial hygienists, can understand all of the information. But as we understand it, and then we are sending the signals back to the marketplace, it all builds on itself. So we need everyone in that ecosystem, I think, demanding transparency at a minimum, and then trying as hard as you can to optimize for health. And don't get discouraged.
That was a great question. Unfortunately, we're running a little short on time, so we're going to have to wrap our discussion here. But before we break, Allison's going to come up and just share a little bit more on resources that are available for those who want to follow up, and just give you a quick preview of our next session.
Yeah, so thank you very much. It was a great conversation. Thank you, Catherine. Green screen. I actually never really understood how it worked before, so thank you very much. And I think John also showing us approaches to different systems that we can use and adopt. And those great questions of John Sarah's. And thank you, Heather, for coming all the way down from Cambridge today to present Harvard's approach to this material. It's really great. Additional resources, we have a health material sustainable building courses on Open Campus. Catherine has participated in them, John has participated in them, Wendy, everybody here has. And now we have captured Heather, so we can put her on there too. Thank you, Heather. Our website that John Sarah already mentioned is a great resource. Go there. John Sarah showed some of these as a start. If you don't know very much about this, or you need additional information, it's a great aggregator of information. It's a great first stop on your journey to discover more information, with great little things about why these things matter. It's a very simple introduction, very helpful. Wendy has been assembling some great information on the HPDC website. There's continuing education there that you can find. Also, how to use Lead 4, an introduction to that. Assembling resources there that are particularly useful. The support portal there, answering questions that come to top of mind once you start jumping into this, extremely important. The repository, finding out which products actually have HPDs, a great resource, and additional continuing education resources there. Materials Matter, AIA's new initiative, check that out. Materials Risk White Paper that Catherine talked about, a scary but interesting resource. This prescription for healthier building materials, put together by ARIC and AIA, is a great resource. COPE, Committee on the Environment, AIA also has some amazing resources, and a call out to Joe Allen from Harvard's Chan School of Public Health. Great resources, research that is happening at Harvard. Great place to find additional information. And a reminder, this was a series of 4 discussions. We've had 3, and the final one is scheduled for January. And it's really looking specifically at affordable housing and beyond. So really addressing the needs of all populations, the kind of populations that are particularly vulnerable and whose needs should be addressed in buildings. So look for a date for that, probably the 3rd week in January next year. Thank you all for coming. It's been a great evening. We have a little reception upstairs if you'd like a drink at the end of this
Library.
In the library, so we can check out the
So
library.
if you want to
We've never
see
been
some
there.
healthy materials, you haven't done that before, please come and join
Yeah.
us. We're going to be transiting. Thank you all for coming.
Thank you very much.
Thank you,
and for tuning
panelists.
in.